All right, so for number 3, I'm going to factor the numerator and denominator. This numerator, let's see, what multiplies to be a negative 12 and then adds up to be a negative 4? You guys think of any two numbers to do that? Yeah.
Negative 2 and 6.
Ooh, negative 2, positive 6. Let's see. Negative 2 times positive 6 is negative 12. Okay, negative 2 plus 6, ooh, is a positive 4.
Wait, what? Oh, I meant negative 6 and plus 2.
Oh, so adjust the signs here?
Yeah, my brain went.
Oh, you're good. You're good. So 2 times negative 6 is negative 12. Okay. 2 added to a negative 6 is my negative 4. Okay, so yeah, that's all taken care of now. Denominator. Let's factor the denominator. Nice, Evan, you got those as well. The denominator, though, this should be, oh, this was months ago. We had some factoring formulas. I don't know if you guys remember. Difference of squares, difference of cubes, sum of cubes. We had some factoring formulas. This one is, so yeah, Evan, that's what I would get as well, but here's why. The difference of squares, a squared minus b squared, it factors into an a plus b times an a minus b. Okay, that was from a while ago. Okay, if you need to brush up on this, you probably want to go look at your notes from before. That difference of squares, and okay, I've got an x squared. My 4, I'm going to treat my 4 like a 2 squared. So it's x squared minus 2 squared. That way I can identify like the a and the b. The a is the x, the b is the 2. So I get my a plus b, so my x plus 2, times a minus b, so like my x minus 2. There we go. All right, and then Evan, you had it in a different order, but that's totally the same thing. That works. All right, now I'm going to simplify by like dividing out any factors. Do you see any of the same factor, numerator and denominator? So those guys? All right, so once I get down to this x minus 6 over x minus 2, I see x's are the same. Can I get rid of the x's? Why not? You're right, but why not? With and they're subtracting, it's x minus 6. Yeah. Which subtraction and then division, those are not inverses. It's multiplication and division. They're inverses. So for that reason, you're right. I have to leave it. This is as good as it's going to get. Put that down here for my answer. Yeah, you got a question? Yeah, so why I cannot get rid of those? Yeah. Okay, so I cannot get rid of those because in the numerator, this is an x minus 6, right? Mm-hmm. And then denominator x minus 2, but it's subtraction in the numerator and denominator. Subtraction, aren't addition and subtraction the opposites? Those are inverses. This is division. This fraction means like divided by. And then division and subtraction, those are not inverses. Those don't undo each other. So it's all still there. Right? Nothing cancels out.
If it was x like plus 6 and x plus 2, could you cancel out or no?
Nope. If it x plus, it has to be inverses. So you know what you can do? You can kind of check out on your own, like pick a number to plug in for your x. 4. Okay. So if I do a 4 minus 6 over a 4 minus 2, that gives me what? Negative 2 over positive 2 gives me a negative 1? Mm-hmm. Okay. If I canceled those x's out though, it'd be like canceling those 4's out. It would end up with a negative 6 over negative 2. It would end up as a 3, which is not true. It's supposed to end up as a negative 1, right? Yeah. So you can kind of check that way, kind of make sure we're on track. But yeah, the main reason why is because subtraction and division are not inverses. They don't undo each other. All right, and then my excluded values, what x does not equal. I can get one of my excluded values from the denominator, but I should have 2 excluded values. I gotta consider, before I canceled anything out, I gotta consider that set of factors. So the x plus 2, I gotta consider that set equal to 0, and my x minus 2 equal to 0. Why didn't I do the x minus 6 equal to 0? Yeah.
It's on the numerator.
Oh, it's in the numerator. Okay, so I don't care if the numerator equals 0. I care about the denominator equaling 0 for my excluded values. Okay, which means my excluded values are at a -2 and a +2. There we go. So then Chase, you were asking a question off to the side. So I finished number 3. Any questions on number 3 before I look at Chase's question? Frills, number 3, you guys are solid on it? Okay, so Chase, I'm gonna just do this over here to the side real quick. You're saying if you had a 3x minus 6, nice, Kate. 3x minus 6 over x minus 2, that actually could be simplified down more because I can factor the numerator still. Remember GCF, greatest common factor? I can factor out a 3 out of the numerator. And now, okay, so now I have some factors that I can divide out. It would just get down to a plain old 3. All right, Chase, are you okay with that? All right, nice. Yeah.
You're doing 6, okay.
Okay.
I was like, where are you pulling 3's from?
Oh. All right. Okay, so get rid of that. We're gonna have to, let's move on to number 4 here. Very similar to number 3, so I'm gonna give you guys a sec. Let's see if you guys can answer number 4 like we did number 3. Yeah, might need to know this formula again. Let's see, Sadie, are you there? Maybe he's not. Let's see, Bailey, are you there? Nice, Bailey. So Bailey, can I have you start, you'll start with the factoring. And then Siler, I'll have you do the simplifying after she factors, okay? Nice, so Bailey, you can't really factor the numerator. That's gonna stay in x plus 4. Come on. But the denominator, let's see, Bailey, let me know what you get for the denominator. Nice, so use the difference of squares again, and 4 squared is the 16. Looking good, you got your x plus 4 times x minus 4. Okay, so for simplifying, Siler, what do you do to simplify this? Any simplifying? Do you see any common factors that I could divide out? So like an entire factor. The x itself is not considered a factor because it's not x times anything. The x plus, oh, the x plus 2 on this one, that divided out, that's true. What about on number 4? Nice, the x plus 4 divides out with the other x plus 4. What is anything divided by itself, really? 1? Okay, so as far as what's left up here, I can say it's like a 1 up there. I would have a 1 over the x minus 4. Okay, so that's like as simplified down as we can get. I still need some excluded values though. So Aaron, are you there? All right, Aaron's not there. What about Destiny? Destiny, are you there? Nice. Okay. So Destiny, let's get the excluded values, like what x cannot equal. What are my excluded values on number 4? So x cannot equal, oops, it already says x cannot equal. X cannot equal a 4. That is true. And there's actually another one as well. X cannot equal a positive 4 and something else. And the negative 4. Nice. So a positive 4 and a negative 4, because you had to even consider, even though you canceled it out, you had to consider all of the factors in the denominator. Okay. So yes, we got a positive 4 and a negative 4. Good, good. Any questions on 3 or 4 here? It's gonna be very similar to this. Yeah.
I don't really have a question.
Okay.
But, I got the numbers that x does not equal just by putting x squared minus 16 equal to 0.
That's true. Okay, you could set this original one equal to 0. I think though, look at this denominator, x squared minus 16, versus like, look at this denominator in number 6.
Yeah.
I think what we had on number 4 in the denominator, setting that equal to 0, it wouldn't be too hard to solve, but not all of them would be so easy. So I do kind of want to get in the habit of doing the factoring. Does that make sense?
Yeah, I still did the factoring and all that.
Okay, cool. Sounds good. All right. So then I'm going to go on to 5 and 6 here. 5, okay. So some stuff is a little easier on number 5. Some stuff people are not a fan of. So like what I think is a little easier is I don't really have to do any factoring. It's all just straight up multiplied. I don't see any addition or subtraction going on number 5. That's kind of nice. The other side is there's 2 variables. You got x's and y's. So pros and cons there. I think I'm going to, first things first, I'm going to treat like my numbers separately from the x's, separately from the y's. So like if I multiply straight across, let's just look at, like I said, just the straight up numbers here. Like what is 8 times 7? And then what is x cubed times x to the 4th? And then what is y times y cubed? I'm going to do them individually, right? All right, so let's see here. Troy, what is your 8 times 7?
8 times 7 is 56.
56. What about your x cubed times x to the 4th?
That is x to the 7th.
X to the 7th. Nice. You added the exponents. You added the 3 and the 4.
Mhm.
Good, good. What if that's what you had to do? If you had to add the exponents, what do I do with these y's? Because I don't even see an exponent on that first y.
So it counts as a 1, right?
Oh, it's like an exponent of 1. Okay, so then if you add your exponents, what do we have now?
4.
4. Okay, so I got y to the 4th.
Yep.
Nice. Okay, so you totally simplified the numerator. Looking good. All right, and then Jessica, will you simplify the denominator? Yeah, number 5. Here, I'll zoom in here. It might be kind of hard to see. Is that better? Okay, cool. So just the numerator. So I would do the numbers separately. So just do the straight up 2 and the 4. What's 2 times 4? Okay, 8. What about the x's? How many x's are there in the denominator? Just one, there's a single x, that's it? Yeah. All right, what about the y's? 3 of them, I've got 2 of them here, like y squared, and then I've got, this is y to the 1st. So you basically we're doing your 2 plus 1 is 3. Looking good, so y to the 3rd. Nice, okay. So we're getting there. I don't think we're totally done yet, because I still can like divide my constants, divide my x's, divide my y's. I can do all that still. Okay. Let's see here. Kate, you're at home, right? Nice, Kate. So Kate, can you do the division simplifying? Like what's your 56 divided by 8? Seven, all right. What about, do your x's. What is x to the 7th divided by, this is like an x to the 1st. What's x to the 7th divided by x to the 1st? Nice, x to the 6th. So kind of your 7 minus 1 is 6. What about your y's? Let's deal with the y's now. Y to the 4th over y to the 3rd. What do I get for my y's? Okay, so just straight up y is like y to the 1st. That makes sense because like your 4 minus 3 is 1, right? And you don't even really need to write the 1. You just left it as a y. Good, good. Okay, so then here's my question, Kate. What's in the denominator? Like I put all that stuff in the numerator. Is there anything I need to like divide by down here? No? No, I don't need to divide. I mean, I could say divided by 1, I guess, but like that's as far as simplifying goes, I don't need to write divided by 1. So there is my simplified answer right there. And they also wanted excluded values. I actually have 2 variables here. I have x's and y's. So I'm going to say I got to have what x does not equal. I also need to figure out what y does not equal. Let's put that on there as well. All right, based on my denominator. Okay, just based on the bottom part there, just the denominator. What can I not plug in for my x? Like what makes me divide by 0? I'm going to set my x's equal to 0. What's x to the 1st equal to 0? Just straight, yeah, x to the 1st is just straight up x. It's just x equals 0. So one of my excluded values for x, not one of, my only excluded value for x is the 0. What about the y's? Same, yeah. Isn't 0 cubed still 0? So the fact that I had no addition or subtraction going on here kind of means that my excluded values are both at 0. Y is not equal 0 here. All right, any questions on number 5? For those of you guys at home, how are we doing? Thanks, Bailey. Nice, Kate, Tabitha. All right, all right. Thanks, Alani. Boys, the girls are kicking your butt. Oh, nice, Chase. There we go. Girls, how about like, let's see here. Like, Mayu, Landon, where we at? You doing okay? Josh?
My connection is really bad and I keep like disconnecting from the Zoom call.
No responses. All right, I'm gonna move on. Mayu, Landon, Josh, I'm hoping I hear from you guys soon. Number 6 here. Number 6, I've got some factoring to do. The numerator, let's do this top left one. Do you guys know how to factor that top left one? Yeah.
You factor them separately and then do the times.
Oh yeah, so I would factor just this top left part first, and then I'll deal with all the multiplication later. So yeah, I'm gonna separate that top left one, the bottom left one, top right. I'm gonna separate each of those. The 3x though, I don't think there's much I can do to factor that guy. That's gonna stay a 3x. But the stuff I circled, I'm gonna do like one of these at a time. So like that top left piece there, my 3x minus 3x squared, yeah. Nice. GCF greatest common factor. They both have a 3, so I can factor a 3 out. Is there anything else they have in common? X. Okay, I can factor a 3 and an x out, which means I'm left with 1 minus x. Okay. Let's see. I took care of that one. Let's do the bottom left one here. This is what multiplies to be -5 adds up to 4. Any ideas here? Oh, +5, -1. So let's see, 5 times -1 is -5, and then 5 plus -1 is a 4. Okay, looks good. top right one, this is the last bit of factoring on this problem. What multiplies by negative 20 adds up to, let's see, what is this number it's got to add up to in the middle? I don't see the number there. Okay, you guys are going like this, 1. It's got to add up to 1. Okay, so what multiplies by negative 20 adds up to a 1 then? Let's see, 2 and a 10.
4 and 5.
A 4 and a 5, both positive, both negative. One's positive, one's negative. What is it?
One's positive, one's actually both are negative.
4 and a 5. Let's see. If I have both negative, negative times negative is a positive 20 though, right? So I think one of these guys is positive, one of them's negative. Which one's which though?
The negative. Look at the X is positive.
Oh, this is a positive X. So you said negative 4, positive 5, like that? Okay, so negative 4 times positive 5 is a negative 20, and negative 4 plus 5 is a positive 1. Okay, so yeah, looks good. Do any of these match up that I can like divide out?
X plus 5.
Oh, X plus 5, bam, gone. Anything else?
3x.
Yeah. 3x, yeah, the 3x. I didn't put it in parentheses or anything, but it is multiplied, right? It's a 3x times this entire x minus 1, and then multiplication and division are inverses. So yeah, those were able to divide out. Anything else? Yeah.
Are the two the same? 1 minus X and X.
Okay, yeah, these look so close, right? But let's see, this one has a,
Right, because the negative is attached.
yeah, negative attached to the x, and this one's like a positive x, but, okay, but what if I factor out a negative 1? Like, what if I change the sign on this guy? So I change the sign on my positive 1, I turn it into a negative 1. I change the sign on my negative x into a positive x. So I factored out a negative 1. Does this now match?
Yes.
They're in like a different order, but are they the same terms? Do they both have like a positive x? Just a plain positive x? Yeah, I think they both have a positive. What about, let's see, my constant negative 1. Do they both have like a straight up negative 1, but not off by a sign or anything? So those are actually the same. If you want to rewrite this, you could. Instead of negative 1 plus x, you can call it x plus a negative 1 or x minus 1. That's exactly the same thing. So if you want to rewrite it like that and kind of make them match up a little prettier, be my guest. Yes. So I factored out a negative 1. I basically changed the sign on each of these guys. I changed it to a negative 1 and a positive x. And then I was like, okay, does this actually, do they match? Like, can I divide them out? And yeah, my negative 1 plus x. Okay, let me treat my number as like, or sorry, my x as a number. Like negative 1 plus 2. Is that the same as 2 plus negative 1? Like, can I add in a different order? Forget the negative. What if I just do like a 5 and a 3? 5 plus 3. 3 plus 5, are those the same? They both give me an 8. I'm good with both of those. Okay, so my point is I can add in whatever order I want. So if I want to make it look a little prettier, make it look like they match up a little better, I can do this addition in a different order. I could put the x first and then a negative 1. And isn't adding a negative, that's like subtracting, right? So that's like x minus 1. So these actually do totally match. I know I had to rearrange the way it was written, but even though they were written in a different way, they still were equal to each other. So I can still divide those out. Oh, Landon, I didn't see that. I'll look back and see what you said. Thank you. All right, I'm gonna look at like kind of my leftovers here, the stuff that I didn't cancel out quite yet. Let's see, I still have my x minus 4. Is there anything else besides the x minus 4? Oh, this guy up here, negative 1. I didn't divide that out either. So I got to do the entire x minus 4 times the negative 1 there. If you want to simplify, you could probably distribute the negative 1 through there. So like a negative x plus 4. Probably be the more simplified version, but there we go. So here's my answer. And as for my excluded values, I don't want to look at my final answer. I want to look at, my work throughout the problem here. Probably my factors in the denominator. Let's see, I had 1, 2, 3 different factors in the denominator. So let's set each of those equal to 0. got my x plus 5 equal to 0, my x minus 1 equal to 0, and the 3x equal to 0. Okay. So if I subtract 5 on each side here, I get a negative 5. If I add 1 on each side, x equals positive 1. This one I have to divide. I gotta divide by 3. And isn't 0 divided by 3 still 0? So like my excluded values, x does not equal a negative 5, a 1, or a 0. Okay. Do I have any questions on this stuff? I only have one problem left. So any questions on this one before I do the last one? All right, you guys at home, you're good? Troy, do you want to go take a lap for a sec? All right, you guys at home, you're good? All right. So if you guys are good at this, I'm going to pick up the last one right here. Find the product, okay, like multiply. Okay, we've been multiplying a bunch of fractions. How can I write this last guy as a fraction? Because I don't see.
It's over 1.
Oh, if it's not written as a fraction, it's over 1, like that. Okay, that's kind of nice. Let's see, let's do some factoring. This x plus 2, I think that's broken down like as good as it's going to get there. All right, 1, obviously I can't factor my 1 any more than that. Let's see, didn't I use a formula up here? Yeah, that I put in the box, that yellow box. That was my difference of squares formula. We also had a difference of cubes formula. We had a sum of cubes formula. You guys are gonna have to reach back to these formulas here. And the reason I bring that up is because I see x cubed minus, and then 27 is something, what can I cube to get 27? Which one? 3? Okay, so like 3 times 3 is 9, times another 3 is 27. Okay, 3 cubed is a 27. All right, so that formula, my difference of cubes, you guys had a sum and a difference of cubes. I'll put this over here. So I factor it. Yeah, does this look familiar? It's a while ago. You have to brush up on this stuff. Okay. So a cubed plus b cubed. It looks like I've got an x cubed, or sorry, not plus, but minus my 3 cubed. So like my a is the x and my b is a 3. So I'm gonna plug in all those a's and b's. We get a x minus 3 instead of a minus b. I've got x squared instead of a squared. My a times b is a 3 times x. And my b squared is a 3 squared. So 9. All right, all right. Which, I don't know about you guys, but that looks really familiar. Doesn't this look like something else I've seen somewhere? Oh, it's the same as this guy? All right, so that's kind of nice. I'm gonna leave those the same. I can already tell that they're gonna divide out. All right, another reason why I'm not breaking it down any further though. Think about it, what multiplies to be 9 and adds up to 3? Let's see, I can have a 1 times 9. I can have a negative 1 times negative 9. I can have 3 times 3 or negative 3 times negative 3. Do any of these add up to 3 though? No, if I wanted to make that equal 0, I'd have to do like the quadratic formula, right? In fact, if you guys do the quadratic formula, you're gonna see this on your homework. If you do the quadratic formula on this to figure out what makes it equal 0, it actually gives you like the square root of a negative number. It gives you like an imaginary. I'm not going to include imaginary numbers in this type of problem. So for that reason, I'm not going to factor this any further. I'm not gonna factor it with imaginaries, okay? And the nice thing is I can see that they divide out already. They're already the same thing. We good? Which means I'm left with the x plus 2 over the x minus 3 times 1. Do I really need to multiply by 1 though? No. All right, I'll leave it like that. And can I get rid of my x's? No. Ooh, no, x plus 2. is divided by, ooh, addition, division, those are not inverses. Okay, this is as good as it's gonna get. My excluded value, x cannot equal, well, my excluded value has to do with what's in the denominator, right? So it looks like I would exclude a 3, and I would, usually I look at what the other factor in the denominator is, but this guy right here, this x squared plus 3x plus 9, it actually never equals 0. If you put this in the quadratic formula, it gives you some imaginary number. I don't have, we're thinking about a graph, right? I don't graph imaginary numbers. So, I mean, you can solve this with the quadratic formula, but you're not going to get anything that's actually in my list of excluded values. Only the 3 is actually in my list of excluded values. Okay. So this question is a little off. It's saying, why is there no excluded value? It's not like there's no excluded value, but why didn't I exclude what I got from my longer factor in the denominator? So I can rearrange this here. So I was trying to say that this, if you do the quadratic formula on it, probably can't factor it right off the bat. Oops, it already is equal to 0. So if I do the quadratic formula on this, let's see, under my square root, I get a, what, 9 minus 36? So I've got a negative number under my square root, which as soon as I have a negative under my square root, that's telling me, nope, I'm not going to put that list, or put that in my list of excluded values. Okay. Do I have any questions?